So let's start Unit 1 now, which is going to be all about linear systems. So the word linear, of course, means lines. And so it's going to be a whole chapter devoted to solving when we have more than one line, either on a graph or as a system or in a description or something. So let's begin with just connecting English with mathematics and doing some graphing of lines. All right, so I want you to think about this statement and then try to pick the best choice that you think goes with it. So a number is doubled and then 3 is added to it. Number is doubled and then 3 is added to it. So which one do you think it is? A number is doubled, so that's going to be 2 times what it was, and then a 3 is added to it. If you have picked C, then you are correct. 2n plus 3 represents that statement. Okay, try this one. 3 less than half of a number. 3 less than half of a number. So take a look at all those options. Pause it if you need to. Which one is 3 less than half of a number? So it's going to be half of a number, and then 3 less than that. And half of a number, and then 3 less than half of a number is going to be B. There's your 0.5. That represents half of a number, and then 3 less than that is a subtract 3. All right, a bakery charges 10 cents per cookie, as well as $1 fee for the box. Okay, a bakery charges, so if they charge something, that means that's a cost. 10 cents per cookie, as well as $1 fee for the box. So again, pause it if you need to. And then let's talk about this answer. So our cost is going to be C equals, all right? So that's your cost, C equals. So right away we can take out A and we can take out C because it doesn't represent a cost. Cost is equal to 10 cents per cookie as well as $1 fee for the box. So notice this is in dollars and this is in cents. So we're going to have to rewrite this 10 cents as a dollar. So that would be 0.10 or just 0.1. So that represents 10 cents or 0.1 of a dollar. So then our answer then would be B. Our cost is 0.1x, that's for every cookie, plus the $1 for the box. James earns a base pay of $20 per day, plus he earns 9% commission on all his sales. So he's going to earn $20 per pay no matter what. And then anything he makes some sales on, he's going to end up making 9% on his commission. Now, when we write equations, we want to change our decimal or our percentages into a decimal. Okay, so it can't be written as a percentage inside of an equation. It has to be changed. So 9% is the same thing as 0.09. Okay, so you can just take your percent and then divide it by 100, and that would give you 0.09. So I'm looking for his commission is going to be 0.09% or 0.09 of all his sales plus the $20 per day. And so what he earns in a day would be, so it looks like it's going to be, it's not A because this is 0.9C, so that would give him 90% commission. That would be lovely, 90% commission. So it's not A. And same here, right? He has commission on 90% plus commission on the $20, so it's not that one. Earnings is 0.09C plus 20. Earnings is 20 plus 0.09C. If you picked either C or D, these are both correct. Whether you want to write it as 0.09C commission plus the $20 per day, or the $20 per day plus 0.09 in commission, either one is the exact same thing. So that one had two answers, C and D are both correct. All right, let statements. So let statements are when we decide what the variables are going to be, and we just make a quick little statement on it so anybody who's reading our work knows exactly what we're talking about. So in this case, we have 7 apples and 5 pears, and it costs a total of $9.23. So the two things we're talking about are apples. So we say let apples equals, and we have to figure out what variable we'd want to use. So I think I'm going to use a capital A for apples. And the other thing we're talking about is pears. And I'm going to let a capital P represent pears. So if I was going to write an equation for this, I have 7 apples, so 7A plus 5P for 5 pears, and that equals to a total cost of $9.23. So that is definitely a statement that represents this description, and these are what we call our let statements. And it's just where you assign the variables so that whoever's reading your work knows exactly what you're talking about. Okay, let statements are going to be very important as we do some word problems within our unit. Okay, so point of intersection. When we graph two lines, those two lines usually will cross at one point, and this is called a point of intersection. Notice it's abbreviated by POI, point of intersection. So what I want you to do is, it says to graph on your whiteboard, but just on your page, you could graph these two equations and then figure out where they cross. So that's your point of intersection. So let me pull out my grid. Here we are right here, and you have your grid, and it's just a matter of doing some graphing. This is why we reminded ourselves like how to graph, was because of this. So if I was going to graph this first equation, y equals 1/3 x plus 4, I'll call this equation 1. So I know my slope is 1/3 and my y-intercept is at plus 4, which means I'm going to go to plus 4 on my x-axis, and then I'm going to go up 1 and I'm going to go over 4. 1, 2, 3, 4. All right, and just to keep going with this pattern, up 1, over 4 would be here. Down 1 to the left 4 would be here. Down 1 to the left 4, because I can go in the opposite direction too. See how I still get this beautiful straight line? That's what I'm looking for. Okay, so I get something like this. Perfect. And then now let's take a look at this second equation. So my second equation, I have a slope of 2. I don't have a run with that, so I'm going to put it 2 over 1, so I have a rise and a run, and a y-intercept of -1. So let's go to -1 here, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and I'll draw a nice line that goes through that. Okay, and then where this hits, right here, let me just kind of point it out. Right there is my POI. It's my point of intersection. Now, this one seems to be a little bit hard to see. It looks like it's at like almost 3, but not quite. So maybe 2.5 and 4.5. That's where it looks like it's to me, kind of 2.5 and 4.5. Take a look on yours. Maybe it's a little bit clearer. But yeah, that's where I get my point of intersection to be. So sometimes, I mean, you just have to do approximate. Now, it's too bad it wasn't some really nice numbers. I'm really precise, because then we could plug them back in to check. But for this one, that's about where it is. And like I said, you're just going to kind of estimate as best you can. We know that our graphs are right, so I'm just like not too sure where that is. Okay, let's try another one. Oh, this one's telling me to check my answer. So hopefully this one will end up nicer. So here's my grid. Okay, feel free to pause the video right here if you want to try this one on your own and then come back and see. I have it written as x plus 3y equals negative 12. So I'm just going to rearrange this, and so I'll go one right here. I'm going to subtract x from either side. So that gives me 3y equals negative x minus 12, and divide by 3 to everything, and y equals negative 1/3 x minus 4. Okay, so this tells me I have a slope of negative 1/3, and I have a y-intercept at negative 4. So negative 4 is down here. Negative 1/3 means I'm going to go down 1 and to the right 4, down 1 to the right 4, and I can go up 1 to the left 4. Remember, opposite directions, up 1 to the left 4. We get this lovely line that looks something like that. And then from there, let's go to the second equation. So equation 2, I'm going to add a y to each side, and then that gives me x plus 4 on this side and y on the second side. And so my slope is 1 over 1, and my y-intercept is a positive 4. So my y-intercept is positive 4, which is up here. Now, 1 over 1 is fantastic. That means up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And see this? And then down 1 to the left 1, down 1 to the left 1, down 1 to the left. And I'm going to just kind of keep going with this because I'm hoping down 1 to the left 1. Oh, I was so hoping that we'd have a nice, lovely point of intersection. Down 1 to the left 1. All right, let me put my line in here. There we go. Okay. And so our point of intersection is right there, which it looks to be at, looks to be at 6.5, -6, -6 point something, and 2.5, so -6 point, it's not quite 0.5, maybe -6.3, and oh, -2.5 it looks like it's at. Oh geez, this is why graphing and point of intersections kind of drive me crazy from time to time, because I look at this and I want an exact value, and I'm just kind of approximating by looking at where these two lines cross. And so what we'll see kind of later on is how to get away from this. So let me just copy these equations so we can do a check. Okay, so I had said our point of intersections were at a -6.3, -2.5. And so -6.3 plus 2 times -2.5. Remember, this is your x and this is your y. So wherever there's an x, I can put in that value. And wherever there's a y, I can put in that -2.5 value. -6.3 minus -2.5 plus 4 equals 0. So, I mean, we're off by a little bit, but it doesn't look like by too much. So -6.3 times 2. This is going to equal out to a -5. And so -6.3 minus 5 is -11.3, which equals -12. So that's pretty, it's close. And then this one's -6.3 plus 2.5 plus 4 equals 0. And that works out to like 0.2 equals 0. So we're really close on that one. Close also, but not quite. So it means that my lines are off a little bit. Oh, it's so frustrating, isn't it? But you're just going to try your absolute best. If it had worked totally, we should have been able to put those points back in for x and y and gotten the true statements. Because we're off by a little bit, I got these false statements. But that's par for the course whenever you're doing graphing. You may just end up, you can graph your very, very best. That's why it's so important to be neat and to make sure that your scales are good. We're going to try our best here to get some good answers, but sometimes when you go to do your check, you'll just be off by a little tiny bit. That can definitely happen. Yeah, so that's graphing with point of intersection. So give it a try, and if you have any